So if we hash n keys into m slots, how many collisions can we expect to have? So the first thing we're going to do here is we're going to assume independent uniform hashing. And the goal of that is to simplify our probabilities a bit. What this means is that the probability that we hash some random key and that the slot that we chose for that key is equal to some other random key, this assumption tells us that that probability is going to be 1 over m. And now the second thing I'd like you to notice here is that there's going to be exactly n times n minus 1 over 2 distinct pairs of keys. And the reason for that is pretty straightforward, but it is an interesting thing to think about. Now, let's think about this in terms of a graph. If we have n nodes and we connect each node to every other node, right? Then I'm saying essentially the same thing, right? I'm going to say that there's n times n minus 1 over 2 edges. And the reason for that is that each node has n minus 1 edges leaving it to every other node. And then there's n of those nodes. So you might think, oh, okay, there's n times n minus 1 edges. But really, you're double counting every edge. So that's why we divide by 2. And that's how we know how many distinct edges there are, or in other words, how many distinct pairs of keys there are in this problem. Now, using the linearity of expectation, we're done, right? We just multiply our two fractions, and then we see that we can expect n times n minus 1 divided by 2m total collisions.